So, let's start gravitation. Okay. So, the Newton's law of gravitation here is this. The force between two masses, m1, m2 is given by g m1, m2 by r square. We have done this. Formula wise, we know this. The only thing that I want to tell you is the direction of this gravitational force. Direction, that is very important. Direction. So, direction of this gravitational force direction, that is on the mass m1, the mass m2 will pull the mass m1 because gravitational force is attractive in nature. So, mass m1 will be pulled by this m2 mass by a force F on 1 exerted by 2. So, 2 will be applying a force on m1 towards the center of m2. Similarly, m2 mass will be attracted by mass m1 along the line joining their centers. Listen carefully, along the line joining their centers and towards the center of the other. So, this would be the gravitational pull on m2 by m1 towards its center along the line joining the two centers, and this will be called force on the mass 2 exerted by 1. So, these are the directions of vector force F12 and vector force F21 in this direction. That is the only thing that we need to consider, direction. Otherwise, we know this formula from class 9, 10, G m1 m2 by r square. G is gravitational constant 6.67 10 to the minus 11. Anyway, next part is this one. We will be doing this sum. Directly we can apply this formula to find the gravitational force between the two spheres. These are the two spheres. Sphere 1 that has a mass 7m and radius 5r, and the other mass has is capital M and its radius is r. Now the distance given is 8r. So what is the force between these two masses? You have seen the numerical. Now these are the options. These are the options. Option 1, option 2, option 3, and this is option 4. Which option is correct? The force between the two masses. Option 4. Okay. Any other option from any other student? Who will say this?
Option 4 হচ্ছে
Huh? Option 3? Who is saying option 3? Or
option 4 আছে
Anushu option 4? Okay.
option 4
Show me bolle. Okay. And who says 3? That is option
2
option 2, Rudrakshmi. Okay. This one.
Sir, আমি option 3 বলেছি।
Orko Alok.
হ্যাঁ স্যার।
Orko Alok. Very good. Very good. Very good. That is the right answer. This is the right answer. And that's why I told you to understand this direction. Understand the direction. Formula we know this. Mass, product of masses, G divided by distance square. What distance? The distance between their centers I had told you. Now let us come to this picture. What is the distance between their centers? Suppose if I draw this distance between their centers, that distance is going to be from this center to this center. This is the distance. This is not the distance. That is given 8r. The distance is center to center distance, this one. Is this 8r? No. Why? Because this distance can be found, the slant distance can be found from this triangle. Say if this is 8r, this is also 8r. And if this is 8r, this distance is 4r. Yes, this is 4r. See this, whether you can understand this or not. This height is 4r because this radius, this mass has a radius capital R. So this height from the ground is capital R, so capital R, so this is capital R. So the remaining part above is 4r. So this is 8r base, this is 4r perpendicular, so this small r will be given by root over of 8r square plus 4r square. And now we can find the force between two masses. G, mass of one, 7m, mass of the other, capital M, divided by the distance, small r square. Small r square is 8r whole square plus 4r whole square. And they make up to 64 plus 16, that is 80. So this is 7 gm square by 80r square, this one. Is it clear to everyone? No. Tell me. And you understood how important small r is. Small r is the distance center to center. So let us be back to this and let us give a little more respect to small r. Center to center. Center to center distance, that is smaller. Okay. So we have done this. Now comes the second sum. This is another sum. Here the force on the sphere 1, force on the sphere 1 exerted by the other two spheres. Other two spheres means sphere 2 and sphere 3. How much force they will exert combinedly together on mass 1. How much will be the force on mass 1 due to the other two masses? I have not written any option here. I couldn't get enough time. But just find the answer. How much would be the force between on the mass m1, on the mass m of first sphere exerted by other two spheres? And all are of mass m, first, second and third. All are of mass m and all are having radius r. That is, they are identical spheres. Waiting for your answer. Very good. Very good, Ishan. Now, whenever you see three circles are in contact with each other, then what inner sense comes alive? That is, join the centers. If you join these centers, each has a radius r. But I am explaining. See, this has a radius r. This has a radius r. So if I ask you what is the distance between the center to center for mass 1 and 2, that is 2r. So let us find the force on the first mass, exerted by 2. Just now we have learned the force is along the line joining the two, and towards the center of the other. Just we have learned. So this would be the force. This one. Let us call it F on the mass 1 exerted by 2. So F12. Okay. Similarly, so let us find F12. F12 would be given by G m into m, that is m square, divided by distance between the two masses whole square. Okay. So this is the force on the first mass exerted by 2. Similarly, what would be the force on the first mass? Suppose ki mass 2 is not there now. Now suppose mass 2 is not there. So mass 3 is there and mass 1 is there. So there would be a gravitational attraction between these two masses. What would be that gravitational attraction? Let us join their centers. I told you joining the center, center to center. See here. The distance would be center to center. So I have joined center to center. Again, they are at a distance 2r. And now the direction of that force. So force on 1 exerted by 2 would be towards its center like this. So that force is again going to be like this. This force can also be called F on 1 exerted by 3. Exerted by 3. This is another force. So these are the two forces acting on 1. Mass 2 is pulling it in this direction. Mass 3 is pulling it in this direction. So those are the two forces acting on that. And we can easily understand that F12 and F13 are equal because G same, M1, M2 same, distance between the centers 2 are same. So forces are equal. And now let us apply the vector idea that we learned. Vector idea, what is that vector idea? We learned in vectors, if two vectors A and B which are equal, suppose vector A is A, vector B is also A, both the vectors are of equal magnitude, then their resultant R equals to root 3 times of any of the two equal amount of vectors. If suppose 5 Newton and 5 Newton are acting at an angle of 60 degree, when at an angle of 60 degree, if two vectors are acting at an angle of 60 degree, then the resultant becomes equal to root 3 times of any one of the two vectors. How? We did this, but just once I am doing that very fast. Vector A, vector B, that is also A. So A square plus B square plus 2AB. B is also A into cos 60 degree. Cos 60 is half. So it will become A square and A square. Why? This cos 60 half and this 2 will cancel. So this is 3A square. So root over of that will give us root 3 times A. So this is the idea in background, and Ishan has well applied this. Ishan has well applied this.
So it should be root 3 by 4, not root 3.
Yes, that's why it would be. Root 3 by 4. I think you told root 3 times of the force. Yeah. And who said that? Root 3 by 4 into G mm by R square, you said. Who said that?
Sir, I had said that.
Yes, right, Madhubi, right. I actually thought you said the factor to be root 3 by 4. I mean, the factor, I mean this factor, I thought. Yes, that is the answer. So now, with this in background, let us find the force between these two which are acting at an angle of 60 degree. Now, why 60 degree? Because I told you whenever we see two vectors or 3 spheres, then we need to join their centers. If you join their centers, you find an equilateral triangle each side of 2r. So all the angles will be 60 degree, 60 degree and 60 degree. So the basic idea that comes that sphere 1 would be experiencing two forces. due to the second sphere and due to the third sphere. In these two directions where the angle between the two forces is 60 degree and the two forces are equal. The two forces are equal in magnitude. So we know if the two forces are equal, then the resultant force, net force on mass 1 would be given by root 3 times of any one force. I was saying that actually, Madhupi. I thought you said that to be root 3 by 4. So the answer would be root 3 times of this force. So F, that is resultant, would be given by gm square by 2r whole square, any one force, into root 3 times. This is the answer. Then let us now come to theories. So let's start. Theory number 1 in this chapter, that is relation between small g and capital G. Relation between small g and capital G. So let us start. The relation between small g and capital G is this. Draw a sphere of mass m and radius r, and after drawing that, write let earth be a uniform sphere of radius r, which it is not, but still we have to write that and assume this, of radius r and mass m. That is given here, r and m. Okay, then second statement, let a small mass m is placed on its surface. Chalo, ठीक है. Therefore, write gravitational force Fg, gravitational force equals to G, m1 mane capital M, m2 mane small m, divided by distance between them is r square. Here we are neglecting the radius of the small mass small m. It would also be having some radius. So center to center distance means radius of first and radius of second joined together. But we are neglecting the radius of the second. Why? Because we have already said that this mass is small. So it would be gmm by r square. So in the next line, write therefore, acceleration due to gravity, g, that is acceleration, that is nothing but gravitational force divided by mass small m. So it will be given by g mm by r square divided by small m cancel, general manager by r square. General manager by r square means capital G capital M divided by r square. So this is the relation between small g and capital G, and this is equation 1 that gives us a relation like this. Now niche lekho, right below this. After this, let us do this. What? G equals to, next line of this, capital G, okay. Then capital M means mass. Mass of what? Mass of the planet, Earth, which we have assumed to be spherical. Remember here, we have assumed it to be a uniform sphere. And a uniform sphere would be having its mass given by this. Volume, 4 by 3 pi r cube means volume, into average density rho. This is the mass. Here we should write that rho is not density but average density. Rho is the average density of capital M, that is of the planet, that is of Earth, divided by r square, okay, divided by r square. So this gives us that small g and capital G are related like this. This is the relation number 2. What is the difference between relation 1 and relation 2? Relation 1 tells us that capital G, capital M divided by R square. Capital M remains capital M if we are on or above or beyond the surface. If we are above or beyond the surface of Earth, then would be G given by Gm by R square, general manager by R square. Otherwise, if we are inside Earth, then total mass capital M of Earth will not pull the object. If you have gone some distance inside Earth, then it would be pulled by a less force. But that would be given by this thing. This relation, I am not saying it would be this much, but this relation will give us the value of that. We have to make adjustments further. So we will be coming to that later. But what theory we were doing? We were doing the relation between small g and capital G. Under that, this is the theory. We found force, Gmm by R square. Then we found acceleration, which came out to be general manager by R square. Small m got cancelled. And then we further found capital M to be this much. Volume into density, and R square R cube cancelled by R. So this is the relation. Why I have written these 4 into inside a bracket? Because these 4 quantities are always constant. Capital G constant, 4 by 3 constant number, pi number constant, and rho, as I told you that it is an average density. Average values are always constant values. That's why rho is also a constant. That's why I have put them into a bracket inside. Now capital R may vary depending on where you are inside Earth. So after doing this, let us do main theories then. Next, give heading variation of G. How small g varies. Variation of G has 4 theories. Among them, theory number 1, that is, right, due to non-spherical shape of Earth. We just now had taken Earth to be a uniform sphere, but here we are considering Earth not to be perfectly sphere. So suppose Earth is assumed to be like this, say, like this. So if Earth is like this, then suppose with respect to the center of Earth, any position on the pole, suppose someone is standing on the pole and someone is standing on the equator. This person actually एक ही आदमी है, same person. The person is moving from pole to the equator. So during the journey, what happens? Tell me, the person is on Earth. That means we've found in this theory that if we consider a position on Earth or above the surface of Earth, then we can well apply this formula, Gm by R square. So let us apply that here. Here, the value of G is gravitational acceleration at pole, Gp, pole. And here, the value of G at this position, let us call it G, gravitational acceleration at equator. So we can always say that G is inversely proportional to R square. When will this happen? It will happen above or on the surface of Earth, because then only G will become general manager by R square. capital Gm by r square. So G is inversely proportional to 1 by r square. And here we see that radius, which radius? Equatorial radius is greater than the polar radius of Earth. RE means equatorial radius, radius along the equator, is more than radius along the pole. This is smaller, this is larger. So more the distance r, less will be G. R more, less will be G. So R is more for equator than pole. So gravitational acceleration on the equator would be less than gravitational acceleration on pole. That means weight of certain thing or a person on equator would be how much weight? It's not G, weight. Weight means mg. That will also be less than this. So, if we buy suppose 10 kg iron or 10 ton iron from a shop on the pole, suppose pole mein there is a shop that sells iron. So, from this shop we bought 10 ton iron. That would be having some weight, 10 ton. Now, if you sell it to a shop or a person who is on the equator, then its JEE would be less. That means it will weigh less. So 10 ton iron you bought, you paid that person for 10 ton iron. When you are going to sell it on the equator, it weighs less, maybe 9 ton. For example, I am saying. So you would be getting the price of that iron for 9 ton only. You will lose money for that. So never do that. Huh? We may do numericals based on this. How? Write this sum. A numerical based on this. That was a theory. Now let us practice a sum. What? If radius of Earth suddenly shrinks, suppose, not practically, theoretically, shrinks by 0.2%. This is very common sum in gravitation. Shrinks by 0.2%. What would be the percentage change in the value of G? That is the question. Now,
So considering Earth to be sphere,
Earth to be sphere, yes, considering Earth to be sphere.
Will be increasing by 0.04%.
0.04%.
0.04%.
Okay.
Sir, it will increase by 0.4%.
Increase by 0.4%. মধুবিকে এখন কিছু বলা যাচ্ছে না ভাই, আগের অঙ্কটাও ঠিক বলেছিল, বাট yes, it would be 0.4%, because we will be back to this sum. Okay, we'll be back to this sum. Before that, let us do this. Which one? Write this thing. By now you have learnt little mathematics. Now do this. G equals to general manager by r square. Okay. Now if we take log of both sides, taking log of both sides, it will become log of G given by log, right side, log of general, log of manager, log of r. Okay. Now let us differentiate this both sides. It is not that for this sum you are learning this. You are learning a technique where you can apply it directly in other cases, like a simple pendulum taken to the top of a mountain and that loses 20 seconds a day. What is the height of that mountain? Similar question. So that's why I'm telling you again, in heat chapter, heat, you will be again facing similar type of sums. Answer, technique, same. Let us learn that first. Then we will be back to the sum. A certain numerical is a numerical only, but techniques, it will help you in for more than a single numerical. Chalo, let us differentiate this. Log g, write dg by g equals to 0, 0, minus 2 dr by r, considering radius to be variable only, because capital M and capital G are constants. So differentiation of them will be 0. So we get what? dg by g equals to minus 2 dr by r. From this relation, we can find percentage change in the value of g equals to minus 2 times percentage change in the value of r. This is our relation.
So 0.4%.
Yes, 0.4%. And now, let me tell you this thing. Those who don't have mathematics, as a subject, let me tell you for them. The idea is here. This is a concept part here. What concept? Say percentage is found by this thing. Final value minus initial value divided by initial value into 100. That is the formula for finding percentage, the basic formula. Now, suppose a value x, suppose some price of a commodity is x, that finally became x2 and initially that was x1, initially x1 into 100. So this would be the change in the price of x when it became from x1 to x2. So this is the percentage change in x. This is the formula. Now, this is algebraic form. If we want to convert it to calculus form, x2 minus x1 is whatever meant by dx. Yeah, x2 minus x1, change in the value of x, that is the meaning of dx in calculus. Divided by x1, means initial value, that is x. So dx by x means just final minus initial by initial. Now, if you multiply it by 100, it gives you percentage. So we can also find percentage change in the value of x by calculus if we apply this idea. So this is the concept part. I have just done that thing here. Differentiated to get a calculus form and then multiplied both sides by 100, but I didn't multiply it directly, I have written this. But if I had to multiply this, both sides can be multiplied by 100, the relation stays same. So now it is dg by g into 100. Okay, so dx by x into 100 type sort of thing. That means this is the percentage change in the value of g. On the other side, minus 2, okay, minus 2. Then dr by r into 100, that will give you percentage change in the value of radius. Okay. Now the idea, how can I directly write this without doing all these things? Because this sum when came in IIT, this sum, when there were two parts in IIT, one screening part, and students who qualified in screening were only allowed to appear for IIT. There was a stage like that. So in that question, this came, in that paper, screening paper, this came. And right now it is ready to come in your school exams, board exams, competitive exams again, other than IIT. So how to deal with these things? Whenever you get a formula, just look at the power that changes. Look at the power that changes. The power is this one. It's, bolo? Exactly, very good. Right idea. I was just going to tell that. Just like error analysis. But in error analysis, error plus error, error minus error, error into error, error divided by error, always those are added up. Remember that idea I had told you. Errors are always added. But here, it may be positive or negative both in percentage case. But similar to that. But here I am telling you this thing, see. Look at the power of the variable term. The power is square, r square. Now look at the power, is it plus or minus? We can easily write this relation as g proportional to r to the power minus 2, just like error analysis here. But in error analysis, we neglect those plus or minus power because those are going to be added up. But here, we need to take care of this minus sign. So, percentage change in R into that power would be the percentage change in G. See that? The last line tells us the same thing. See this last line? The percentage change in G would be equal to percentage change in R into the power with its sign included. Percentage change in R into minus 2. Minus 2 कहाँ से आ गया? It's power. That's it. So you need not to do all these things. I just showed you how it comes. You can do them directly. So now going back to the sum. This was the sum. Okay. Now we will write G equals to, as in the answer part, Gm by R square. Therefore, percentage change in G is given by minus 2 times percentage change in the value of R. Minus 2, and then percentage change in the value of R, it shrinks by 0.2%. Two things are important here. Number one, 0.2%. Number two, shrinks. It doesn't expand. Shrinking means decrease. In calculus, you need to be acquainted with another thing. What? If I write acceleration equals to rate of change of velocity, dv by dt, then it is acceleration. But if I write minus dv by dt, then we understand, okay, this is retardation. That means in calculus, if one quantity increases, one quantity means, for a ratio, if the denominator increases and the numerator decreases, then we put a minus sign. Here minus sign in calculus will mean that for increase of one factor, the other factor will decrease, or for decrease of one factor, the other factor will increase. That is the meaning. That means with time, as time goes on increasing, the velocity goes on decreasing. That's why minus dv by dt. And that is the meaning of retardation. This is not acceleration now. We understand that. Retardation, okay. And we express that with a negative sign in calculus. Similarly, here negative sign will mean decrease and positive sign increase. Now tell me, shrinks, that means decreases, what? Radius. Should we write this 0.2 plus or minus? 0.2 to I have written. Now should I write plus or minus? Shrinks. Minus. Shrinks, decreases. So minus 0.2. This percentage will become negative if it decreases. And if it increases, the percentage becomes more. Positive. Positive percentage change means increase and negative percentage change means decrease. So it would be negative. As it is given that it decreases. So finally we get positive 0.4%. And as the answer finally becomes positive, that means it increases. So as radius of Earth shrinks by 0.2%, gravitational acceleration increases by 0.4%. That is the answer. Okay, so you got that. Now, remember this 0.2, multiplying the to get the percentage change by its power minus 2 is only limited to small percentage changes. But for large percentage changes, you should be sticking to that percentage formula, final minus initial by initial into 100, that basic idea, this one. This is the base formula to find percentage change. Anyway, तो चलो next theory में चलते हैं. Next theory is theory number 2, that is we were doing variation of small g. So small g varies due to non-spherical shape of earth. That means as the distance varies r, so the value of g also varies due to non-spherical shape of earth. If it was a sphere, perfect, then all the radius would have been same, so it wouldn't have varied. Anyway, chalo. So the next theory is due to height. If we move above the earth to a certain height, then again g will decrease. We know this. Again g will decrease. The value of g decreases. So next theory, due to height. And after doing this simple theory, we will be doing a numerical. So let us consider earth to be a uniform sphere of radius r and mass m again. But we are not going to write that theory again, because we know that wherever you have to do this theory, just write those two lines all the times. All four theories you would be doing. This is the second theory. So this is center of earth. This is the radius of earth, capital R. Draw this. And capital M is the mass of earth. Draw this. Now, say on the surface of earth, the value of g on the surface of earth, suppose at position A, the value of gravitational acceleration is g. But if we move to another position, here, say at point B, then at this position, this is where? B is where? B is jaw. B is h height above the earth's surface. B is at a location which is h height above the earth's surface. So, at the position B, the value of g is g suffix h. See, we would be applying a suffix depending on which factor g is changing. Here g is changing due to height. That's why I have written g suffix h, just to distinguish it from the value of g on the surface. Okay. So there the value of g is gh. Let us assume that. Let us write simple things. Haven't I told you that on the surface or above the surface, I mean outside earth, we can always apply general manager by r square. Outside the surface of earth, again we can write general manager, but this time what is the distance of B from the surface of earth? From right. From the center of earth, this distance is r plus h. This distance is r plus h. So this time we have to apply r plus h whole square. H is height from surface of earth. So just dividing these two, gh by g, we get this by this, right side by right side. If you divide them, we will get r square by r plus h whole square. This is our relation 3. Relation 3. Now moving a little forward, right up to this. Okay? You are writing this, I hope. Liquid, right? Okay. Now moving a little more further with this relation, write g by gh. Gh by g. We got r square by r plus h whole square. That can be written like this. Next line is this. Actually, it was r square by r plus h whole square. So what I did, I have done this thing. I divided each term by r square. Now think of this, r square by r square, 1 h plus r whole square by r square, that will become h plus r by r whole square. Now h by r, I have written h by r by r, I have written 1, then whole square, I have written whole square. So that is the one line missing from here. You may not write this line as an explanation because this is class 11, no problem. So you can directly write this, and then let us carry this out further. Equals to 1 plus h by r whole to the power minus 2. 1 by x square means x to the power minus 2, just like that. Now write if h is very, very less than r, only if this thing happens that the height you moved beyond Earth's surface is insignificant compared to the radius of r. Radius of Earth is very large, 6,400 kilometer, not meter. So compared to that, if you move to the top floor of Burj Khalifa building, nothing. So h up to the top floor of Burj Khalifa would be nothing, negligible compared to the radius of Earth. So in those cases, we can write this thing, h very, very less than r. Then what we can do, that again we can write this relation gh by g, which is given by 1 plus minus 2 will be multiplied h by r. I had given you a video, remember, at the beginning of class 11. There I had told you the idea behind this is this. You may not write this idea, but you need to understand this idea. 1 plus x whole to the power n will become 1 plus nx if this x is a small number, very small number. Smaller than what? Smaller than 1. Very, very smaller than 1. The smaller x is compared to 1, more correct the answer is if you calculate it with your calculators. So I had given you this video thinking that you would someday require this, and the time has come, my soldiers. This is the time that you should understand this. So this idea you may not require to write this, so I am keeping it in the side. So this is the relation. Just applying h very, very less than r, this power gets multiplied with this ratio h by r. This h by r ratio becomes very, very less than 1. Very, very less than 1. Suppose h is Burj Khalifa, I don't know the height of Burj Khalifa. Suppose let me take it 1 kilometer, I don't know how much. This is h. And radius of Earth is 6,400 kilometer. So you understand what ratio h by r will give you, 0.000 something. So we can neglect that. I mean, not neglect that, we can consider that to be very small number compared to the value 1. So we can multiply this power like this, minus 2 into h by r. Bas, that is the answer. That is the answer, we got it. So gh equals to g into 1 minus 2h by r. Bas, that is the relation. H is height above the surface of Earth, r is radius, and g is the value of gravitational acceleration on the surface of Earth, and gh is this thing, the value of gravitational acceleration at point B, which is at a height h from the surface of Earth. There the value of gravitational acceleration is gh. Okay. Now let us be on to this sum. Which sum? Right. On moving above Earth's surface, by a height h, the value of g decreases by 75%. Find h. As you move up, the value of g decreases. It decreases by 75%. You have moved such a distance up, so that value of g has decreased by 75%. So how much have you moved above the surface of Earth? That is the question. Okay. Exactly equal to capital R.
Sir, আমারও তাই এসেছে।
কত?
H equal to R. H equal to R.
H equal to R.
Sir, I got H equals
How much?
R by 8.
3R by 8.
Yes.
Okay. মধুপি, তুমি কত বলেছিলে?
Sir, exactly equal to R.
নাও, হাত বাড়াও। নাও, নিলে? Nobel Prize, Nobel. Yes, right answer. Very good. Those who got it, H equals to R. Right answer. And those who got it, 3R by 8, they have made a slight mistake. Mistake in calculation? No. Their calculation is okay. Mistake in understanding this thing. This formula is well applied for any type of sum related to height change, this formula, because no special cases are involved here. Gh by g equals to r square by r plus h whole square. But as you move to, oh I kya ho gaya? As you move to this page, this formula, this has a limitation. What limitation? To come to this line, you have to move through this line. And to come to this line, you have to pass this idea first. I mean, cross past this idea. And then you can move to this, and then you can get this formula. That means if h is very, very less than r, height is insignificant, then only you can apply this formula, otherwise not. And when you are doing this numerical, you never know, I mean before doing the sum, how much is h. So when you don't know the value of h, how can you say that h is very, very less than r? You cannot say. Unless it is given in the question that consider h very, very less than r, never take this formula for carrying out numerical. Don't do this, because this is for theory purpose only. 3 marks, 4 marks theory, if you get this in your school exam, do this. Otherwise, this is not applicable. I mean, 90% not applicable for sums, and 10% they are applicable when you find numerical where it is given that consider h very, very less than r. Then only apply this. But when you don't know the value of h, how much is it going to be, do not apply this. Then back to basics. The basic formula that we did, this one, number 3. So going by that formula, gh by g. But I was impressed by the confidence. Exactly equal to h equals to r. Nothing more, nothing less. I mean, you didn't say this, but that was inner voice. Anyway, gh by g equals to r square by r plus h whole square. And neither you have made that mistake. The mistake, there was a trap that 75% means 3 by 4. You didn't make that 3 by 4. That is very good. Those for those also who got the answer 3h by 8, they also didn't fall into the trap of this. That is also good thing. Always look at the positive sides. At least you reach to that answer. Anyway, what is the trap here? decreases by 75%. So how much value of G is still retained? What is the present value then? If I decrease the value by 75%, present value would be 25%. And the present value 25%, that means G at a height h would be 25% of G. That means 1/4 the value of the gravitational acceleration on the surface of Earth. So Gh by G is 1 by h, 1 by 4, then r square, r plus h whole square. Square root both sides, square root both sides. So 1 by 4 becomes half, r by r plus h. R by r plus h. From this, h is exactly equal to r. Nothing more, nothing less. Okay, right answer, chalo. H is equal to r. So far, so good. Now we'll be doing the third theory. That is, the third theory is the variation in the value of G due to depth. Due to depth. Earth. If you go inside Earth, then what will happen? So, suppose there is a mass m placed at position A, where on the surface of Earth the value of G is G at position A, and the radius of Earth is center of Earth. Radius of Earth is capital R. So Earth is a uniform sphere of mass m and radius r, that same line. Now suppose if we go to mines, colliery, like iron mines, gold mines, by a distance x. Notice karo, we are considering distance x from the surface of Earth, and later when we would be doing simple harmonic motion, SHM, then we would be taking this x from the center. Remember this, later we will be going there. So here we have moved a distance x from the surface of Earth up to this position. So at this position, when this mass came, let us call this position to be B. So at position B, the value of G becomes Gx. I had told you that we put the suffix depending on which factor is changing. Height, then it's Gh. Depth, then it is Gx. X means the depth we moved up to. So if we move up to a distance x, to a position B, this part of the Earth, only this part of the Earth will attract this mass at a depth x. Only this part of the Earth will attract this mass towards its center, and remaining part, that will not attract. Later I will be telling you again the logic part, a little logic. You can write it side by side, but not necessary to write if this comes as a theory in your school exam or board exam. This is the logic part. Logic part you may write it for later. You will be requiring this. What? Write this. Gravitational field intensity. Gravitational field intensity inside a shell, spherical thin shell, be it thin or thick, here same answer will come. Inside a shell is 0. That's why the force acting on any mass is 0. Why? Because force is given by the formula intensity of the field into mass. This is the formula for force. Later you would be doing that. Later, not now. E stands for intensity. What intensity? Gravitational intensity. So gravitational intensity E and mass m, the product of those two gives us the value of the force experienced by a mass, and that never exists inside a shell. That means if I want to draw a picture of that, अगर मान लो इसका पिक्चर ड्रॉ करना चाहता हूं तो ये ऐसा होगा. देखो, if this is a shell and like this, and if you are, this is a shell, and if you are anywhere inside this shell, here, here, center, here, here, anywhere, any of these dots, then gravitational field intensity E will be 0 everywhere at any position inside a hollow shell. So if the person moves to position B, notice karo, if the person moves to position B, then the outer part which forms a shell type thing, this outer part, inside that shell, the person at B is inside that shell part where no effect due to the shell. But outside the remaining part, what is the remaining part is the matter of concern. The remaining part, this much, is of radius, how much? R minus x. That's it. That's it. You need to understand that only. So coming from A to B, by a distance x, the gravitational acceleration will change. Why? The force decreases. Why? Because this annular part means this shell part loses its effect on this mass. Effect means force. So the force decreases. Anyway, chalo. Let us start with this. How to start with that? Simply put, it is like this. Next, write this. Therefore, at A, G is given by general manager by R square. Okay. As we are moving inside Earth, I had told you that on the surface of so as we are if we are on the surface or move away from surface of Earth, then we can put G equals to general manager by R square. But we are now going inside Earth, so we will not put that formula. Which formula? Then remember this. These are the pages we have done. Dig. This one. We are not going to apply general manager by R square. We are going to apply this formula. So dig. Aya, no. Dig. No. Dig. No. No. Now write. G, I told you about four constant things. G, 4 by 3, pi, rho. Rho being average density into radius r. Okay. And at B, we can similarly write G given by this formula. We will follow this. This is a constant term put in bracket, I told you. So this will remain same. G 4 by 3 pi rho. Only the radius now has become R minus x. See this? This radius has now become, this green color radius has now become how much? R minus x. So you can simply write R minus x. Otherwise, you may find this relation, general manager by R square, from this also, if you want to show logic. G equals to general, okay, then manager, capital M, manager, may be written like this, 4 by 3 pi R minus x whole cube into density divided by R minus x whole square. Chalo, general manager by R square. This is the manager part. Mass of the inner part, not the shell. inner part, that is of radius r minus x, is given by 4 by 3 pi r minus x whole cube into density rho divided by the distance of position B from the center now is r minus x. So, square of that, r minus x whole square. So, again r minus x square, r minus x cube cancels by r minus x. So, I have just written that thing here, and this is the logic part. Okay. So, keeping this a little away from this, yeah, this is the thing. Let us write equation 1 and equation 2, and let us write g suffix x here, because this is the value of g at a distance x, at a depth x. So, therefore, on dividing equation 2 by 1, g at a depth x by g equals to, this bracket cancel, only remains r minus x by r, and that only gives us 1 minus x by r. So, g suffix x is given by g into 1 minus x by r. Just write here at the center, x equals to r. At the center, x equals to r. That means if x equals to r, so x by r will become how much? X by r will become 1. So, 1 minus 1 means 0. So, g becomes 0 at the center. But that's it. That is the theory. Based on this theory, just notice one thing. The value of gx, notice one thing, the value of gx, is there any x square, x cube, root over x type term? No, it is only x. So, we understand that its graph is going to be a straight line, whereas when we found the variation of g due to height, it was square term. Remember gh by g, that was given by r square by r plus h whole square. So, there was a square term of h. So, if we write gravitational acceleration along y axis and distance small r along x axis, small r is the distance from center of earth. This is distance from center of earth. Then the graph between gravitational acceleration and distance will be like this, straight line first, and here the value of r at the beginning was 0 at the center of earth. On the surface of earth, it became equal to the radius, and beyond the radius, it again decreases like this. It becomes curved because I told you that on the surface or above the surface, g proportional to 1 by r square or distance square. You can say this r square. See, when you write capital R, you mean to say radius of a planet or earth. But when you write small r, you mean to say any distance. So, you should work with any distance.
Sir,
Huh? Bolo?
sir, at r equal to 0, r square, sir, doesn't it become infinite?
Actually, it is not defined at r equal to 0. Not defined r equals to 0. But we may do only one thing, that we can avoid drawing this from 0. Just like you draw those PV graphs. Suppose PT graph you are drawing. How do you draw this graph? Can you draw this graph like this? We cannot, because here t is 0, absolute 0. So, practically which is not possible yet to achieve. Similarly, here is also it is not possible, because at the center value of g changes and beyond the scope of our understanding right now, because with this theory you cannot explain value of g at the center. with this theory, assuming Earth to be a sphere and the temperature does not change, so small g doesn't have any effect of temperature, but density does have. Density, that doesn't stay constant. That's why, otherwise, for board level, you can draw it from origin, but if it is, if you see that something is asked about whether it should touch origin or not, then yes, you are right, it should not touch origin. It should be dotted at the origin because it is not defined at the origin, I mean center. Otherwise, it will become infinite. Okay. So, this is the graph, and at this position, this is the value of g on the surface. If suppose this picture is not clear to us, how they draw these figures and pictures, and at the center, where is center, what is the origin, okay, then this is it. This is it. Actually, when we are at the center of Earth, then the value of g here, considering to be 0, value of g, it is plotted here. As we move to another position, say here, then the value of g, this position, you understand, this position is less than capital R, less than radius, so less than this. So here the value of g would be this much. So when you reach the surface of Earth, that means here distance from the center has become equal to that of the radius of Earth. So that is meant by this. And here there is a small height h, I mean a height h that you have moved away from the surface. So the value there again decreases and becomes this much value. But here we understand another thing, that is for g to be equal, I am not disturbing this picture. Suppose if I take another page, for g to be equal from this graph, do you understand this? That this is the value of g and this is r and this is the graph. Straight line, then curve. So there would be 2 points always, say this value. What do we see? This is g, okay. This is g by something, a little less than g. So that value can be achieved for 2 positions. This is position 1, and clearly understandable, this position 1 is less than capital R, radius of Earth. And also for position 2, then also the value of g becomes g by something. So there will be 2 answers for a certain value of g. One above the Earth's surface and the one below the Earth's surface. The value of g would be equal. If the height is not too much, that means if height is small, height above the Earth's surface, then we can take gh to be g into 1 minus 2h by r, as I told you. Remember those who got the answer to be 3r by 8, that thing. And gx is always, it doesn't depend on any condition, is always g into 1 minus x by r. Now if it is given that gh, that means value of g at a certain height h from Earth becomes equal to the value of g at a certain depth below the Earth's surface, then we can equate the values of gh and gx. Like if you want to understand this value here, bolo to value of g at position 1 should be written gh or gx. Tell me this, at position 1. It is gh or gx? Very good. Very good. This is gx. Because this is inside Earth. and r equals to capital R, that means you cross past the radius, then you are outside earth, then it would be GH. So if the two values are equal, then we can equate these two as G into 1 minus 2h by R equals to G into 1 minus x by R. G cancel, 1 cancel, so we see 2h by R equals to x by R. H equals to x by 2 or sorry, ঠিক আছে, or x equals to 2h. That means for small height above Earth's surface, the value of G suppose becomes 0.1% of G. I mean decreases by 0.1% of G. So for same decrease in value of G, if you have to go inside Earth, then you need to go inside Earth, double the height of the height you went outside Earth. Chalo, due to, now this theory would be easier for you because you have done the last theory. Due to diurnal motion of Earth, mane rotation. Diurnal motion mane spinning with respect to its own axis. How do technology help me? Let me take a little technology help. Suppose this is the axis of Earth. Okay. See the suppose this is Earth. Earth rotates from west to east. Radius of Earth. এটা ড্র করো। Lambda is the latitude of the place where small m is placed. Don't ask me too much about geography. You know better than me. Baki, lambda is the angle with the horizontal, azimuthal angle. So suppose a position is here, the position of mass m is here. That means it is this, the radius at that position makes an angle lambda with the horizontal radius of Earth or equator of Earth. So as Earth is spinning from west to east, Earth is spinning from west to east, so does the mass. Mass m is also spinning from west to east, but the radius of the mass depends where it has been placed. If the mass was placed here on the equator, then the radius of this mass would have been how much? Radius of Earth. If you place the mass here, the radius of that mass would have been a little less than r. So like this, we have drawn this to make the picture neat. Draw this. চলো হয়ে গেছে, ড্র হয়ে গেছে। আচ্ছা, হোয়াট ইজ এম? হ্যাঁ বলো। Yes, yes, yes. It is centrifugal force. Suppose this is a stick and this is a rod and this is a mass. Now if you are rotating the mass like this, so this is its own center of rotation. So centrifugal force would be acting opposite to that center. তো এখানে দেখো, okay, so this mass m is rotating with a smaller radius than capital R, that is smaller, and its own center is O dash here. So centrifugal force, if it rotates in with that radius, centrifugal force would be acting opposite to its own center of rotation, m omega square r. Okay. Now I'm erasing this and I am making this a little small. Sorry. Now, there are two forces only. One is being visible, another is not being visible. Which force is not being visible here?
The Coriolis force.
Oh, yes, Coriolis force is there, but for Coriolis force, there has to be another.
Tension of the mass, which আমরা string থাকবে ধরুন।
That tension here is in the form of gravitational attraction. And what you are saying, Ishan, that is Coriolis force will act if there is a relative motion with respect to a rotating body. Then here the mass sticks to Earth, so we are neglecting a Coriolis force here. If it is the air envelope of Earth and that air moves over Earth, then comes Coriolis force. But that is beyond the scope of our board syllabus. So as of now, let us stick to this thing. What? Another force, if there was a string, okay, then it would have been, it would be attracted towards the center by means of a string, then the force is tension. But there is no string here. It is connected to the center of Earth. We are not connected to the center of Earth by a string. Then the gravitational pull, that's why it is given in gravitation chapter. This direction, the gravitational pull will be acting, and that is nothing but our friend mg, weight of that body, mg. We call that gravitational force to be weight of the body, mg. Okay. Now, one problem is there. mg and m omega square r are not along the same direction. We want to find this thing, what? Net force, right? Net force towards the center of Earth. Net force towards the center of Earth, capital F equals to net force towards the center of Earth. Okay, there is mg. No, but there would be some effect of m omega square r. How? A part of that, and in other words, a component of that force will be opposing this mg now, and that component would be at an angle lambda. Think of this. If this is lambda, this is lambda. So this angle is lambda. This one, latitude of the place. So this angle will also be lambda. So at an angle lambda, the component would be m omega square r, the main force, into which component? Cos component, cos lambda. Now we understand this thing. Now do not consider m omega square r. Just think of two forces, one mg being attracted towards the center of Earth and one that is away from the center, that is m omega square r cos lambda. So the net force I am writing here, net force is mg towards the center and away from the center, that is m omega square r, which component? Cos lambda. Bas, this is the net force. As it is being clumsy, I am going to the next page. Just remember this. This is the net force acting on this body, or acting on us, acting on me, you, anyone. This much. So, if force is that much, then let us write, therefore, acceleration g suffix lambda. Again see, g changes here due to rotational motion of Earth, diurnal motion. That means, and that becomes different for different latitude. That's why we are putting suffix as latitude, lambda. So g lambda will be given by, see, g lambda is nothing but a sort of acceleration, and acceleration can be found only by force divided by mass. Gravitational, we may not write gravitational force because net force divided by mass of the body. Okay, so force is m. If we take m common from that, g minus omega square r cos lambda divided by m. Yes, cancel. Things feel easier when we get something cancelled. So, it is equal to g minus omega square r cos lambda. This would have been the answer, g minus omega square r cos lambda, but it is not the answer. Why? It is not the last line, I mean. Why? Because, let us go back to the picture, or I can show you here also. If this is Earth, now suppose this is Kolkata here. So if it is Kolkata here, it is easier for us to find the radius of Earth. We know this radius, capital R. But it is very difficult for us to know this value, small r. The distance of a place from the axis of Earth, this distance of a place from the axis of Earth, small r, it is very difficult for us to find that for every place on Earth. So we will try.
The value of a capital R cos lambda.
Very good. Oh, very good. So as it is difficult for us to find smaller, we will replace smaller. That's why I have taken a bracket here. We will replace smaller by capital R and by this angle lambda. This angle is also lambda because this was lambda. So alternate angle. Now from this triangle, this box triangle, we can find that small r is given by capital R cos lambda. See this? Small r is given by capital R cos lambda, isn't it? See this? This is small r. This is capital R. This is 90 degree. This angle was taken as lambda, so is this angle lambda. Now, side sticking through this angle is base, and base is given by hypotenuse cos theta or cos lambda. So, hypotenuse here is r cos lambda. Yes, right answer. So, let us be back. Chalo, let us do this. So, and let me keep this a little away from here. So, I am trying to replace g minus omega square, okay. R cos lambda, that smaller here is being replaced by capital R cos lambda equals to g minus omega square capital R cos square lambda. This could have been the answer, the last line, but it is not. Why? Because we can have another line. How? And how does that help us? We will take g common from these two terms. So, it will become 1 minus omega square r divided by g into cos square lambda, and that is the last line. Yes, we got it. And why we have taken g common? Because in earlier cases, we found the relations like g suffix h equals to g into 1 minus 2h by r, g suffix x equals to g into 1 minus x by r. So, here also we get g suffix lambda equals to g into something. That's why we took g common, so that it becomes g multiplied by another thing, 1 minus omega square r cos lambda. But this is the theory part. Theory part is okay. So, g changes due to omega of earth, diurnal motion. So, write two special cases here. Write at poles, lambda equals to 90 degree. At poles, lambda equals to 90 degree.
Final equation में cos square lambda ही होगा.
Cos na, yes. Cos square lambda, yes. Take. It would be cos square lambda. This cos square. Okay. Now do write at poles, at the poles of earth, this angle lambda will become 90 degree at the pole, or south pole 90 degree. So, lambda equals to 90 degree, which gives us g lambda equals to g into 1 minus omega square r by g, then 0. Cos square lambda is 0. Cos 90 degree it will become. And as this is 0, total term is 0, so it is only g. That means what? That means a very important thing. What? Therefore, there is no effect of diurnal motion of earth on the value of g of earth on g at poles. Now, students should understand the effect of these things, not the writing itself. What is the effect? Question gives like this. If suddenly angular speed of earth, rotational speed of earth becomes double, becomes half, then the gravitational acceleration at the poles will become double, half, 4 times, 1 by 4. No effect. Which would be the right answer? No effect. Those are the applications of this. So, at poles there is no effect due to the rotational motion of earth. But, next point and the last point, at equator, on the equator or equatorial region, on equator, what will happen? Lambda equals to 0 degree. This will give us more interesting result. on equator, lambda equals to 0 degree. Therefore, G will give us, G lambda will give us G into 1 minus omega square r by G, bus, that much. So this is for the equator, because cos square lambda becomes 1 because lambda is 0 degree, no angle. So this was it. Only take note of these special cases. Number 1, omega square r by G nearly equals to 1 by 289. How? Omega, we know the formula, 2 pi by capital T. Now you know the value of T for Earth's diurnal motion. Earth takes 24 hours to complete a rotation around its own axis. 24 hours means this many seconds. So time period of Earth, 24 hours. So we can find omega, calculator mein you can check it. Then radius of Earth, capital R, we know this, 6400 kilometer, that means into 3 meter. Then G, average value of G you can take 9.8. If you put these values in calculator to find omega square r by G, you can get nearly equal to 1 by 289 square. 1 by 289. Now, it can be written as 1 by 17 square. And that has got a consequence on this. What? Next point. If speed of rotational motion, that is angular speed of Earth, omega dash, becomes 17 times the present omega. Suppose Earth becomes mad and starts rotating 17 times faster than today's speed. If this thing happens, then let's see what will happen. Then on the equator, so there are two conditions. Condition 1, Earth has to increase its speed 17 times than the present value. Take. Earth has to increase its speed 17 times than the present value. Condition 1. Only this condition will not do anything. There has to be another condition. What? On the equator, where lambda equals to 0 degree. There, G lambda will become G into 1 minus omega dash square R by G into cos square lambda. That cos square lambda becomes 1 now. We know that equator lambda equals to 0 degree. Got the answer? See here. On the equator lambda 0, so 1 minus omega square R by G only. This cos square lambda is gone now. That has become 1 now on the equatorial region. So on the equator, it becomes this much. So it is this much. 17 omega whole square R by G. So it is this much equals to G into 1 minus 17 square into. Now, do you understand this? Omega square R G gives us 1 by 17 square. So it would be 17 square into omega square R by G, that is 1 by 17 square. So 1 minus 1, 0. So G lambda is 0 then. That means if Earth starts spinning 17 times the speed as that of the present speed, then everything will fly off from equator. Only equator, no other place. So what would be mg? 0. That means everything will fly off to space. So objects fly off to space. And this is note 1, note 2, note 3 is last note. That is, what would be the change in weight of a body? Change in weight of a body due to change in weight of a body due to diurnal motion of Earth. The change would be mg, original g, minus mg lambda if g changes due to rotational motion of Earth. So this is the change in weight. That would be how much? M common, g minus g lambda. That would be m common, g minus g into, then what is the value of g lambda? G into 1 minus omega square r by g, this factor, into cos square lambda. Cos square lambda. So this becomes, if you open the bracket, what will happen? If you open this bracket, first bracket, what will happen? G and minus g will cancel out, and then minus and minus, this becomes plus. And this g cancels with this g. M omega square r cos square lambda. So mg minus mg lambda. Now the things in physics, when we cannot relate these things to the questions that appear, then it becomes tough. Otherwise very easy. See, I am telling you this thing. I am showing you how it may become tough, appear tough, and how it may become very easy once you understand this. See, this is the value of weight. Acha, leave weight. Think of g lambda. This is the value of g presently we are having. We are having this value of g. This is another thing, that this value of g is different for Kolkata, different for Delhi, further different for Australia. Why? Because the places change, so does lambda, latitude. So depending on latitude, this value of g changes. So let us be back. Currently we are having the value of g as g lambda actually. That is the present value. So this is our current weight. G into m we are doing. So this is present weight. Now the question comes like this. You will be facing this sum. Numerically you will be finding. What? If Earth suddenly stops rotating, you will find this. You will find this sum. If Earth suddenly stops rotating. Now tell me, if Earth suddenly stops rotating, let us be back to the original theory that we had. If Earth suddenly stops rotating, this is the general formula we got due to diurnal motion of Earth. If Earth suddenly stops rotating, which of the quantities on the right hand side will become 0? Take, and to be very precise, the only quantity that becomes 0 first if Earth stops rotating, which quantity, which exact?
Omega.
Very good, yes, very good. So this omega becomes 0, and as omega becomes 0, the whole thing becomes 0, only leaving behind g. So g lambda now becomes equal to g. So can we write this thing? Where was that? Here. So then the weight of a body will become mg perfect. So this is the weight when Earth stops rotating. So this is the weight when Earth stops rotating. So the question that comes, at a place where lambda equals to 60 degree, at a place lambda equals to 60 degree, how much would be the change in weight if Earth suddenly stops rotating? Now students get confused. How can we understand if Earth stops rotating? If Earth stops rotating mg, Earth not stopping rotating, current weight mg lambda. So what is the difference? This difference. What is the formula? M omega square r into cos square lambda. Lambda given 60 degree, cos square lambda 1 by 4. So m omega square r by 4. And you would be given 4 options. So that is the idea. Okay. So write this down. তাহলে দেখো if lambda equals to 60 degree, এখানে লেখো change in weight equals to change in weight equals to কত হবে? m omega square r into cos square lambda, cos 60 degree half square. That means m omega square r by 4. Bas only this much of sum.